Hi, this is Mrs. Sykes, and today we're having a look at surface area to volume ratio. Now, in another video, I've already talked about why this is important in terms of the biology. This video is all about calculating. It's about the mathematics of what's going on. So for surface area to volume ratio, you need to take your surface area and divide it by the volume. So if we were looking at a cube, we would be comparing the surface area, which is the amount on the outside exposed to the elements, and the amount that you could pour in and it be contained by that shape. So surface area and volume. So we're going to start off by sorting out our surface area. This is the net of a cube. So if I folded this up, it will make a cube shape. In order to work out the surface area for the entire cube, what we're going to do is we're going to separate those off for a minute, and we're just going to focus on this one square. I'm going to use my ruler and I'm going to measure how far across this is. So we're looking at 7 centimetres. Now I have done that relatively roughly because I want to keep these numbers easy to follow. So it's 7 centimetres across. And that's a square, so it should be the same in both dimensions. So 7 centimetres by 7 centimetres. So now what we need to do is get our calculator and work it out. You'll have a calculator in the exam, but I still recommend that you use the calculator, especially for things that are quite easy, because it's very simple to make mistakes. So 49. 7 centimetres by 7 centimetres is 49 centimetres squared. Now when we draw squared, it's a little 2 and it's floating on the top. Okay, now that is the surface area of a square, not the cube. So we now need the rest of the net back. So we've got 1, 2, 3, 4, 5, 6 times that. So our surface area is the 49 that we've already calculated times 6, because there are 6 sides. And again, calculate it. So 49 times 6 will give us 294 centimetres squared. And again, the little 2 is floating just to one side. So that is our surface area that we need. So if I was doing this in an exam, what I would then do is I would underline that in a different colour, because that's one of the numbers that the examiner will be looking for. Great, okay, so we've now got the surface area bit. Now we need to work out the volume. So if we fold this into a cube, how much stuff would fit inside it? If I filled this up with water, how much would fit? So this one you are probably more familiar with. To work out the surface area, you do 6 times the surface of one square. To work out the volume, this one's quite easy. It's that number, by that number, by that number. So again, you can measure it again if you want to, but it's still going to be 7. So we've got 7 centimetres times 7 centimetres times 7 centimetres, because we're now in 3D, so it's 3 dimensions. So, calculator, 7 by 7 by 7, 343, 343 centimetres, but because we've now had 3 elements, we are now in 3 dimensions, it is now centimetres 3, which is called centimetres cubed. So we've now got 2 numbers. Our volume we have now got as 343 centimetres cubed. And again, it's helpful for the examiner if they can find the bits that you are trying to show them. Especially if, like me, you have very messy handwriting. It's even more important to make it clear to the examiner what you're doing. So scribble it all away, do it on your calculator, make a right big mess, then get a pretty pen and highlight the most important sections of your calculations. So now what we need to do is our surface area, 294, divided by our volume, 343. And that comes out as that number there. Now, we have measured to the nearest centimetre. As a general rule, unless it specifies number of significant figures or number of decimal places, you should only ever really give one more significant figure than you measured to. So we measured to the nearest centimetre, so you only really want to be going to one more decimal place. So I write out the entire thing as it is on the calculator. 571, and then I'm going to write rounded to 0 point. Now this number here is bigger, which picks that up to a 6, which picks that up to a 9. So rounded to 0.9. Okay, and that is the number that we need. It's a ratio, so 0.9 to 1. 2, 1, because it's a ratio. And again, using the pretty pen, 0.9 to 1. And this is the surface area to volume ratio for this particular